Hello, this is Aaron from Sibling Rivalry. Today I'm going to be showing you how to load in your printer profile into the Kingroon brand Cura using your G-code that came on your SD card.
A machine that can make copies of almost anything.
So, just to start out, the things that you're going to need today is obviously a computer with Cura installed. It can be Ultimaker Cura, or it can be the Kingroon 3D rebranded version of Cura. It really shouldn't be any difference between the two. I know the Kingroon 3D version is around Cura 3.7, I believe 3.71. But this feature should be available in modern versions of Cura as well. So, aside from the computer, you'll also need the SD card reader that came with your Kingroon printer and the SD card that came with the Kingroon printer. If you have all the files intact that came with it, then that's perfect. If you don't, we'll actually have a link down below in the description that'll have a copy of all the files from my SD that hasn't been used for anything, and you can copy those to your SD card if you need, or you can just copy the G-code out if you need that. Essentially, we're just making it accessible to anyone who wants it. So, first thing you do, plug SD card into SD card reader, plug that SD card reader into your USB slot on your computer, and it'll load up right here. So, well, I have mine set up to auto display when a new device is entered. Yours might be different. You might just have to go into your PC and then select, it usually shows up as a USB drive, and then just from there, there's all your files. So this food clip, fast G-code, and Guardian extruder G-code are what we're going to be using today. So I'm just going to minimize this, go back to Cura. So what you want to do is select the file option. You scroll down here and select the option that says load profile from G-code. So you click that, and before we get too far ahead of ourselves, just look at all the different settings that I currently have set on my printer. And now we click this. I'm going to load the food clip because I found that it prints the best on my printer by default. You could use the Guardian if you find it prints at a better resolution. Really, it's based on preference. So you'll notice that a few of the variables there changed, some things updated, and on this page, everything's kind of set to a new default. So I had previously set this to 0.1 layer height because I was printing some high-resolution files, and it's actually reduced the print speed down to 30. So from here, what I usually do is I just take the print speed, set that to 60 because that's a good minimum. Realistically, your printer can do 60 if not higher for the print speed. That's in millimeters per second like it says there, so some printers can get up to like 150. That's going to depend on your calibration and a few other things, but 60 is always a good start point. Realistically, any quality printer that you're building should be able to do at very least 60 millimeters a second. Now it has the preset temperature here for PLA of 210 and bed temperature of 60. I personally just leave it at that. I find 210 works great for PLA. If I get a more tricky color or something that the pigments affect the flow, I'll increase it maybe up to 215 or 220 depending on how it prints. But other than that, it's fine. I'm going to reduce this layer height down to 0.1 like I like it. And fill density, I'm actually going to set that to 15%, which is what I like to do. Really doesn't make a huge difference, like 15 to 20. The 5% difference really isn't noticeable in material or time. Your support type, this depends on what you're printing. So touching build plate and everywhere are two similar but very different things. So I'm going to load a file here and we'll see if I can show you what that looks like. So there's an ornament that I've been printing for Christmas for a few people. This nice one here, kind of hangs from this section down at the bottom. And as you can see, it's got a very small area that actually touches the print bed. So this is a place where support or platform adhesion can come into play to really help. So as you can see, it's just slicing the G-code up here. I'm just going to turn this back to 2 just so this is going to take us like 3 hours for it to slice. And I'm going to set the support type to touching build plate. So what that means is anything that is a direct overhang of the build plate itself, essentially anything inside of this shadow square, will have support. So any major points there. You can go in and adjust various settings here. You can adjust the way that the support is. You can adjust its infill essentially. And support angle. So like that's the minimum, as it says right there, it's the minimum angle of an overhang that will get support. So 90 degrees, you're not going to get anything. 0, you're going to get everything. And then these are just kind of like air gap amounts, essentially. I usually just leave them as is and then go into the expert settings on the main page and fiddle with it there. So I'm going to bring you to the layer view. And it's going to take its time rendering here. So let's just skip down so it doesn't have to render as much. And then you can see the infill, or support I should say, being generated right there. So that's that teal section. I should really look into investing into a new laptop. Something with a little better GPU performance. But yeah, you can see it right there. And if we go through into the actual support material, if it'll let me, you can actually see the individual layer lines. So that's the 15% layer infill. And it does a little outer perimeter as well. And yeah, so that's what a touching build plate looks like. If you do everywhere, it gets a little more intense. So what everywhere will actually do, once this loads, you'll see, it literally fills, like a hollow part like this, it fills it with support material. So once this generates, I find the infill always takes, or not infill, well, the infill and the support always take a long time to load and render because the toolpaths are more complicated for that. It's easy to do the outer perimeter G-code when you look at it at a software level. So yeah, it's just the way that things work, and because the support material and the infill use the same sort of optimization and similar programming, you get the same sort of thing. So I'm just waiting for it here. Okay, so yeah, you can see it right there. It actually goes in to the part here. It didn't do that before. It just supported the outside here and the overhang there. But now it's the whole thing is just filled with support. And you'll actually see here, it'll fill this with support as well. I accidentally printed this with full support the first time that I did it, and it came out like pretty much a brick, and then I had to just like poke at it with a knife to get the loose parts out. Knife and tweezers and pliers, always good for removing support. So I'm just going to switch this back to the normal mode. Let's do a brim. So now we're going to show you the different things for platform adhesion. So a brim adds a single layer, it says right there, flat thick area around it. So it's kind of like, traditionally it was called a skirt, but now it's called a brim, I guess because a skirt's become a separate thing. Skirt's like that outer purge line that you see, and in some slicers you can actually have the purge line encapsulate the part, so it'll purge on each line. and it'll build it up, and it'll actually work kind of like a heated chamber or like a build chamber for that individual part. And let's see if we can look at this in the layers mode. It'll give us an idea of what the brim looks like, and we're going to just turn off supports. This print actually works great without supports. If anything, supports kind of detract from the quality, I've found. So, let's see, is this going to load? It's going to take a while to load because it's loading the rest of the whole geometry. And recording while I'm doing this probably isn't the best option for slicing. Probably why you don't see a lot of 3D printer streamers on like Twitch and whatnot. There you go. There's the brim. So it just kind of does like a single layer piece that kind of helps with adhesion. It's kind of like a suction cup almost, the way that it works. It widens the surface area so there's more to hold on, so that the whole part doesn't tip off, or just kind of as things cool, it doesn't pop off or tumble. So that's actually how I've managed to print this ornament. Now if we do a raft is actually like a brim, but it's multi-layer and it has an air gap. So there's actually a separation between the raft and the part itself. A lot of times rafts are used or intended to be used for unlevel print areas. So if your bed isn't perfectly level or your system isn't perfectly square, a raft will account for that to a certain extent and allow you to print. I know with the early PrinterBot 3D printers, or not PrinterBot, MakerBot I should say, sorry. PrinterBot never really had this problem. MakerBot, the machine was just essentially this rigid block. The bed you couldn't really level unless you modified it really heavily. So you'd use a raft, which kind of allowed for some variance in there if something wasn't square to itself, or because it had 4 separate lead screws for the Z-axis, it could wobble very easily and twist and be at a weird angle, which even the slightest misalignment would cause print failures. So yeah, let's see if this raft loads so I can show you guys. There we go. So it prints a little block right there. You can see it's what, 4 or 5 layers thick, and it just doesn't render it for the rest of it because it's inconsequential. Okay, so turn that off, go back to normal mode. Woo! And we will turn off raft because I actually don't use that. Nozzle size you don't want to adjust. Actually, before I get ahead of myself, filament diameter. So with filament diameter, you want to typically just leave that at 1.75. If you're noticing some weird issues and you're buying really cheap PLA, or running a different printer, maybe you switched out the hot end to run the 2.85 or 3mm if you're running an old 3mm system, you'd adjust it for that. But if you want really quality results, what you can do is you can take a length of the filament. You don't even have to remove it from the spool or anything. Just take a pair of calipers and just measure along the length of the filament, like every inch or so, and measure the diameter, write it down, and then you do the average of those measurements, and that will give you the average diameter across the length of the spool. The more you do, the more accurate it's going to be, but there's a limit to, like a sane limit to how much you would want to do. The flow rate, ideally you want to keep this at 100%. If you're noticing some weird issues, you can always try fiddling with it, like if you're under extruding, but usually that's a sign that there's something else other than flow rate. Flow rate should always be 100% in a perfect system, so usually there's other variables like diameter or even temperature that would affect it. We'll just edit that out. Okay, so nozzle size, back to that. Nozzle size, you're going to want to leave at 0.4 unless you've switched out for a new nozzle. So 0.4 is the nozzle you get. you can get a replacement nozzle on Amazon. You can buy whole packs of them, I think, for like 15 bucks. And you can get hardened ones, yada yada. And you can get different diameters. So unless you're changing out the nozzle, the two that come with your printer are 0.4. So you want to stick with that. Retraction, 40 millimeters a second is fine, and 4.5 is fine for the distance. If you're noticing a lot of stringing, you can increase this amount here. Like you can turn it up to 5 and fiddle around with it, see what it does, how it works, and how it benefits you. If you're noticing that there's weird issues at the start of the print, like at start of each layer, you can also reduce this amount and it'll retract the filament less. It'll retract less of the filament out of the nozzle, if that makes sense. So for quality here, you've got the initial layer thickness, that's 0.3 millimeters. So that is your first layer. Your first layer should always be thicker than the rest of your layers. So as you can see here, the rest of the layers are 0.2, 0.3. You want it to be a little thicker so it has that extra bit of material and thickness to stick to the bed. And you want the initial layer width to be 100. If you notice that you're having issues with that, you can increase it. With a 0.4 millimeter nozzle, you don't want to increase the initial layer thickness past 0.3. Otherwise, you're going to have weird issues and it probably won't stick to the bed. On the topic of the nozzle size, just going back to that, I realize I'm kind of ping-ponging back and forth. You want your layer height to always be evenly divisible out of your nozzle size. So 0.2 or 0.1 or anything in there that can evenly go into, or can go into 0.4 an even amount of times. I know I'm not using the greatest terminology to explain that, but I believe Prusa Printers has a calculator on their site that will give you different layer heights that will work for your nozzle. And yeah, let's go back to this. So cut off object bottom. So this is used for if you have something like a sphere or some weird polyhedron and it's not printing because it's got like it's got a constant curve to it. So essentially you clip off the bottom of an object and it will flatten it and print from that. So it makes it easier to print. It does have the downside of course, if you're trying to print a perfect sphere, you're not going to get a perfect sphere if you use this option, but you'll be able to print a sphere much easier, for example, because you won't have to use as much support or anything really. You could hypothetically do this and print a sphere that would be pretty close to an actual sphere. And it's 3D printing. You're not going to get a perfect sphere regardless. You're not investing billions of dollars into polishing it. So dual extrusion overlap, that's not really going to come into play for most of us. Unless you've modified your Kingroon printer to do dual extrusion, you can just leave this alone. Essentially, it allows for a certain overlap between the two extrusions, like the two extrusion paths. So if you're doing multicolor, it could like overlap a little bit like that, so that they fuse together, so you don't end up with like a part inside of a part, or like the eye falls out of like the character that you're printing because the eye is done in a different color than the rest of the character. Now for travel speed, you can leave that at 150. Realistically, you're not going to notice any real difference if you change this up. Like you could try increasing it, but you're not going to notice a huge difference. There's a limit to how fast the printer will go to begin with, as well as you've got a limited space for it to actually accelerate up to that speed. And it's not going to really improve your print time a whole bunch because it's just the travel speed. So it's only when it's not extruding, so it hops from point to point. So like if I extruded this part here and then it decided it, for whatever reason, the slicer decided the optimal route was then to go and print over here, it would just stop printing, pull the extruder back, like retract, and then hop over here at 150 in theory, and then start printing over here. So you wouldn't get any real benefit. It's not going to change your print time really by any amount with these size printers. If you were printing like a 1 by 1 meter build area, then you might notice it. But for small scale printers like what we have, you're not going to really notice any change with that. Now with bottom layer speed, you always want to keep this low, as well as infill and like the bottom top, and all of these you kind of want to keep low relatively. Inner shell, you can always keep that at the actual speed that you do your regular extrusion at. So that's the inner layer. The outer shell, because you're doing something and you want it to look nice, you want to go slower. You could always try speeding this up, and I've seen people get some really nice results with faster outer shell speeds. Your top and bottom speed, that's just like the speed of the top and the bottom does. So you want to go slower so it doesn't melt and do weird stuff, or you're not extruding properly and it's hopping around. So yeah, as long as you got a part cooling fan, you should be fine. You're probably fine without a part cooling fan, to be honest, but you'll notice an improvement if you install a part cooling fan. Infill speed, you want that to be a little slower than the actual print speed, so that you don't get too much jerk into that inner shell and like weird artifacts as a result. Bottom layer, you always want to go low and slow for the bottom layer so that you get nice adhesion. And then after that, you can speed up. You just want that first layer to go down really nice and stick really well. And yeah, for the next set of things here, there's the cooling fan option. Always keep that checked. Even if you don't have one, it doesn't hurt to have it enabled, because sometimes your printer firmware will have the actual fan for cooling the heatsink on the extruder set as a cooling fan. Now, for minimal layer time, that is the minimum time spent in a layer. So it gives it a cooldown, essentially. So if it's less than 5 seconds, it's going to pause. So if your layer, like near the tip here, if it's less than 5 seconds, the hot end will move out of the way, wait 5 seconds, and then go back in. And it does that, essentially, so that you don't get a huge pooling effect where like things are kind of like magma and they just lump on top of each other. You can try increasing this if you don't have a cooling fan, and you'll notice some benefits to that. Plugins I'm not going to really get into here because they're a little weird. There's really, all the stuff that's already in here is fine enough. You don't really need to add anything unless you know exactly what you're doing. Your start and your end G code, this is going to stay the same unless you add a bed leveling probe to your printer. And then you'll just have to add in whatever relevant G code in here, and then just save everything. So once you've got your profile all set up the way that you like it here, and you know that it works, you just save profile, and you just save this anywhere on your computer. You can see I've got a couple here. I've got my base one, and one that I've done to like test things out. So yeah, you just type in yada yada yada. Here is a test, and then you would click save, and it would save, and then it would read from that every time you open it until you do an update. Like that would push it out of compatibility. So yeah, I know there was also, I showed you guys in a previous video how to add a new machine, but in case you missed that, oh, you can see my OBS setup here. Ooh, you just go through here. So configuration wizard pops up, you click next, asks which printer, you say KP3, you click next, it says congratulations, and you press finish. I just canceled it because I have way too many of these already from doing different demos and stuff like that for people. Expert settings will give you kind of a bigger rundown of a lot of these things. If you click on these additional options buttons like here on the support, it'll open up a similar thing to what you see here. As you can see, it's pretty much verbatim what you're seeing right there. So it just kind of gives it all in one spot, which is nice because there's some things you don't see out in the other area. And yeah, it's just nice to kind of have everything in one spot so you can look at it and figure out what you're doing. I don't really do the bed leveling wizard in Cura personally because your printer has a bed leveling wizard built in with SmoothieWare, and that's what I use on mine. I know some of you guys are switching over to Marlin. I don't think I'm going to switch over to Marlin. Maybe I'll try it on one of my printers, but I did Marlin on the last like 5 printers that I've owned and built and whatnot, and I haven't really. It's good. It's better than like early stuff like Sprinter by a long shot. It's way better than Sprinter. But Marlin's just okay in my opinion. It's not like amazing. It is when you're doing DIY stuff. It's like honestly a godsend. But when your printer comes with SmoothieWare or SmoothieWare clone, for me that's perfecto. So I think that about covers everything for today. If there's a certain feature on here that you wanted me to cover more in depth, let me know in the comments down below. If you like the video, please give us a thumbs up. We really appreciate that. We're going to have a link down below, like I said, for the files from the SD card. We're also going to have some links for like the Kingroon printer and some filament and stuff if you guys wanted to order filament. We appreciate you using our affiliate link. It allows us to build more videos and do more content, more in depth. We can afford to do bigger things. And yeah, if you have something to say, give us a comment down below. If you're subscribed, we really appreciate that. And if you're not, please subscribe and ring the bell for notifications so you don't miss out anything that we're doing. All right, so I'll see you in the next one, and have a great day. Bye for now.